Hello, and welcome to A Bird's Eye View. In this series, we'll be discussing everything school bus related from the perspective of a leading school bus manufacturer. I'm Brad Beauchamp, Alternative Fuels Manager at Bluebird.
I'm Steve Whaley, Business Development at Bluebird. We're going to discuss my favorite topic, all things propane this season.
And I'm Albert Burleigh, Vice President of Alternative Fuels for Bluebird. So let's hop on the bus and let's get started.
Hello, in this episode, we're going to talk about Propane 101 and propane basics. And I have a couple of experts with me, Steve Whaley and Ryan Zic. Steve, so tell me a little bit about yourself. Where are you from and how did you get here?
Well, I've been spending a lot of time in the propane industry since about 2006. So I've learned everything that there needs to know about on-the-road use of propane, or what a lot of folks call auto gas. And we've had a tremendous ride with getting propane into school buses throughout these last 10 years.
School buses?
Yes.
Propane in school buses?
Propane
I
in
thought we were just cooking burgers and steaks.
Hey, if it's so clean to let it touch your food, think about how clean it is while it's burning an engine in a school bus with children around.
That's a fair point.
Yes, it is.
Ryan, tell us a little bit about how far you traveled to be here with us today.
Well, I'm with ROUSH CleanTech up in Michigan, where we build the engines for those Bluebird school buses that you guys were talking about and send them down this way to get installed in those school buses.
Awesome. Lots of good Propane 101 pieces to be able to discuss here then, because school bus, who would have thought that would be something that'd be powering a school bus?
Well, you know, it is the third most used motor fuel on the planet. Next to gasoline and diesel, propane gets used in more engines than any other fuel.
So it's the third most popular, and Ryan can build an engine for it. How do we put that all together to make it make sense for a school district or a school contractor
Well, it makes
using their buses?
lots of sense, because we are the biggest producer. We, the United States of America, is the largest producer of propane in the world.
So we got a lot of this stuff.
We have a lot of. We're not running out of this stuff anytime soon. As a matter of fact, we use about 10 billion gallons here in the United States every year, but we produce 30 billion gallons. So I've got 20 billion gallons that we ship overseas to 30 million vehicles all around the world that use propane in their vehicles.
That is just an immense amount of propane that's going around the world.
Yeah, if we did our job better, we could use more of that here in these United States and get more clean vehicles for us instead of everyone else around the world.
Yeah, when you look at what this is doing for fleets, it feels like the worst kept secret, something that we should be doing so much more of right here.
Yeah, well, this podcast is going to go out to everybody, and they're all going to learn about how we can make that happen.
That's awesome. So tell me a little bit about propane and LPG. What's the difference between LPG and propane?
It's synonymous. Propane is a little bit more common today than LPG. But in a world application, autogas is the most popular term for it. So you can hear autogas, you can hear propane, you can hear LPG, but it is exactly all the same energy source that comes out of the ground here in the United States more than any place else. And it comes out of the ground with all the other anes, you know, the methane, the propane, the butane, the pentanes. All of those come up out of the ground here in these United States, and we use them in their respective places. Propane actually happens to be the heaviest of all of them, and it has the most energy content, and so it's a liquid, so we can put it in pipelines, we can put it in rail cars, we can move it through transport trucks, so it's extremely portable, and it gets into every community in the entire United States.
I think that's an important point that you brought up, Steve, but they're all the same. So we get that question a lot, right? Well, is it the same as what I use at home to cook with? Or are there different grades of it? So I think if you could touch on that distinction, that's a question we get all the time.
It is. It is the exact same fuel. And, you know, you'll hear the term HD5, which is common for most propane throughout the United States.
Assuming that means heavy duty, right? That's the heavy duty propane? No.
Heavy duty. No, it's 95% propane, and so there's other materials that get in there that are innate, and it's not a problem. But we keep it at HD5 so that there's a standard for all your wonderful engines, so that they know exactly what they're getting all the time, and for filtration processes.
So is it fair to say from both your perspectives that HD5 is no different than the rating on diesel or gasoline. We have octane ratings. We have ethanol in the gasoline supply, and HD5 is just a way to categorize propane.
Yeah, it is. And to your point, it is the exact same fuel that goes in that grill cylinder that cooks your food.
Yep.
So now tell me a little bit about the basic side of how this can propel a school bus down the road. Ryan, how with these engines you're building, are these specially built propane engines? Is that what we have here? Something that's somewhat exotic?
It's something very familiar with just slight little modifications, and all of a sudden we could use existing infrastructure to propel the vehicle, right? So we start with a gasoline base engine, have some minor changes in valve train material because our fuel's drier than other fuels, right? Gasoline has a little bit of lubricity to it, and with that minor change, the system is so similar to what people are familiar with gasoline. Very much parallel. And by design, we really have it that way so that it's familiar when you open the hood. It looks a lot like what a technician or a fleet has seen before.
So it's really easy for someone that lifts the hood to identify the components. They're not looking at something that they're going, I wonder what that is. That's
right.
The Knudsen valve. It's behind the third Fetzer valve, right?
Yeah, they're going to see something that looks a lot like a Ford V8. Very familiar.
Very good. And minor modifications, is that costly, those minor modifications, or is this just coming right out of the plant that produces that engine?
Yeah, it's coming right out of the engine plant. So Ford builds two variations of their engine. One would be the standard way. It's going to be a gasoline-powered engine. And then with that minor variation they call the gaseous prep option, they'll install those valve components for relatively low cost, hundreds of dollars.
So just a small incremental cost to the engine, and it's able to run on propane.
Yeah, essentially.
Mm-hmm.
So how did we start propelling school buses with propane? How did that get started?
Well, we've been running propane in engines for a long time. Any spark-ignited gasoline engine can run on propane. We've done it in ground service equipment for airports. We've done it in the backpack blowers that we're hearing outside sometimes. Anything that runs on gasoline can run on propane. But when it comes time for school bus application, I mean, who better to give the most clean fuel to than our most precious cargo? So you guys started doing that, what? How many years ago?
For ROUSH, I mean, it really goes back to 2008. And then with that partnership with Bluebird, that started in 2012.
Okay.
Yep.
So how many of these school buses, we got like one or two out there or what?
Yeah, I think we've hit the one or two celebration, and I think we've rounded the corner on 20,000. And so they are out there delivering to schools every day.
So there's 20,000 of these vehicles doing that already. And Steve, you keep touching on clean, right? So what makes propane cleaner for use in a school bus than other fuels?
Go back to the periodic tables, and we're looking at
we're going to get into chemistry now. This is going to be awesome.
C3H8. We're talking about a very hydrogen-rich fuel. Okay, and we all know how clean hydrogen is. Okay, but propane has 3 carbon atoms that bind all 8 of those hydrogen atoms together. If it was pure hydrogen, then it would be slightly cleaner, but it makes it a whole lot harder to manage pure hydrogen. So with propane having those 3 small carbon atoms, we bind that together, and a lot of people that I know have called it stable hydrogen. Which is a really good way of saying how clean it is and how easy it is to move around. It's a liquid at about 100 psi on a 60-degree day outside. So we're not talking about pressures that are more than pneumatic tools in a shop. So it's easy and inexpensive to keep safe.
So Steve's given us the Mr. Professor version of it. So that's when you have to adapt it to feed or fuel an engine. I know you said it's very much like a gasoline engine. What is that? What does that look like? How do you get this fuel from the fuel tank to the engine then?
Well, when Steve mentioned stabilized hydrogen, the best part about propane, when you look at it with the other clean fuels, is that it liquefies easily. And because it liquefies easily, we can mirror a gasoline fuel system. So both, you'll look at side by side, have fuel pumps in the tank, right? And what are they pushing? Liquid up to a fuel injector. So both look exactly the same. Now, as Steve mentioned, there's some pressures associated with propane, but we're still dealing with a liquid fuel. And the other part that's important is when you liquefy it, that fuel gets really dense. So now we can store enough to have a really good range on the vehicle, and we don't have to sacrifice really in any of those critical parts of a fleet's operation.
So good range, it's liquid in the tank. It uses familiar components that are already out there in gasoline vehicles today. On the other side of it, as it's burned, it sounds like, from what Steve says, less carbon. How does that come out the tailpipe?
Well, when we look at it from a tailpipe perspective, everything across the board is pretty much lower. There's a couple key parts that we focus on because, the regulators are focusing on them too, right? So NOx is one of those that we've heard a lot about over the past few years with diesel. And if you look at that, we're actually able on propane to certify to an ultra low level, so 0.02, considerably lower, 90% lower than the federal level right now. So really good tailpipe emissions, but we're not having to add a bunch of after treatment on to do that. The emission system looks just like a gasoline vehicle, simple, passive, catalytic converter type stuff.
So after treatment's something that we've been using for decades. That's what you're saying. No, nothing different than what we've been using in a catalytic converter
For decades.
Yeah, to be able to do.
Well,
fuel.
propane doesn't have the particulate matter in the fuel itself, so you don't have to put on a particulate matter filter like a diesel engine does.
That's right.
So you don't have that. So that's kind of a gimme. And on the NOx level, it's substantial. I know you go to the EPA and CARB regulations of 90% less, but West Virginia University actually did a onboard study where they put a new propane bus and a new diesel bus, and they put their mobile emission equipment on there to find out exactly how much less it was. And they rode it around for several months, and they determined that the propane bus was actually 96% cleaner in NOx than the diesel bus. So we're doing a huge reduction.
So a
here.
huge reduction, and just to think that university students were still on the school bus wave, testing those school buses, is kind of interesting, isn't it? They never left it behind.
And what they found in that study, and I think a lot of us don't really think about, but a school bus is so different from an over-the-road truck, right? Yeah. It needs to stop a lot. It needs to idle a lot. We need to go low speed all day. And if you look at how the diesel emission system was designed, it really likes to be using high power utilization, really constant heat and all of that good stuff. And that's where that emission system gets into the sweet spot. And if you look at propane, it's linear, right? Less power output, less is coming out of the tailpipe. More power output, more is coming out of the tailpipe.
So you're saying it's all about the duty cycle and drive cycle of what school buses typically entail.
Right? Yeah, propane's a really good fit with the high idle application of a school bus.
Mm-hmm.
So propane's the third most popular motor fuel in the world. It's the same fuel you've telling me that we use in cooking and heating and all that. How long have we been doing this? How long has propane been in existence?
It's been a while. I mean, it's always been as part of, in the old days when we were refining gasoline and diesel.
I noticed you pointed to yourself when you said in the old days.
In the old days, yeah, because I'm that old. I was way back there. No, when we started, using this program, we were flaring it off because it was something that we didn't want in our gasoline tanks. It was evaporating out and getting. So the old days, you see those flares going off refineries, and up until about 20 years ago, most of our propane was a byproduct of that refinement of gasoline or oil into gasoline and diesel. Well, now most of our propane, about 75% of the propane here in the United States, is a byproduct of all the natural gas mining that we do. So all those anes that we were talking about earlier that come up out of the ground, propane is a byproduct of that refinement. And so we do have a lot of it. It's very clean. And as Ryan was saying, it's a liquid. And so as a liquid, we can move it around just like gasoline and diesel and make it, very viable for a motor fuel. And you guys talked about range. How far can those propane buses go? If you put a big propane tank in that Type C bus, what kind of range are you talking about?
It's always a loaded question because duty cycle and all that stuff and route miles and that type of thing, but pretty comfortably 400. And when you start getting into field trips, right, we look at a fuel economy on a field trip being a mile per gallon, maybe a mile and a half per gallon better than what it does on a route. So now all of a sudden that jumps up, and we've had people report back to us that they're well over 500 miles on a field trip, right? Because it's highway miles. Just like your car, your fuel economy jumps up considerably.
So similar fuel economy, has the range needed to do the vocation, the drive cycle and duty cycle of a school bus even on trips. Let's shift to safety for a minute. Is this a safe fuel? Is propane safe for running in a school bus?
Everybody watches Hollywood, okay, and James Bond in that scene, and where he takes his Walther 9mm and he shoots at the propane tank at the embassy. You know, that's the view a lot of people have of propane. I actually did a safety video way back in the day where we had a police interceptor with a propane tank in the back, and we had several law enforcement agencies in a safe environment. The fire department was there and shooting at it, and basically they're just denting the tent, and until they got an armor-piercing round to go in it, it didn't do anything. But then it went, psh, you know, and they kept shooting because I wanted to spark, and we wanted to see that Hollywood blow up that never really happened. It's kind of like your grill cylinder out on the back deck. You know what goes out first is those igniters. You know, and so they don't work. So you turn it on, and you go inside the kitchen to go get your matches, and you forgot to turn it off. So, you know, you take that match and you put it in. What happens?
You don't have to trim your eyebrows for a while.
Well,
You get a good whoosh.
you get a woof. Or,
There you go.
in technical terms, we call that a flash. Okay, but I like woof better. But does the tank blow up?
Nope.
No. I mean, this tank underneath is, you know, like 6 inches away from a, you know, almost 1,800-degree flame. Why doesn't it blow up?
I think we're missing a component in that tank. What is that?
Something, you know, air, you know.
Oxygen, yeah.
Oxygen, kind of have that. So it's very, very safe. But when we get into the crash test parts, when those crash tests have to get done by the government crash test, what's involved with that?
Yeah, that's required on a school bus, right? So you have a 4,000-pound crash sled that hits the tanks, and it doesn't matter what fuel type it is. Propane's no different. Full load of fuel. And then after impact, it's going to sit there, and they're going to check for any pressure leak or anything like that for 30 minutes after that impact. So I think what I'll say about safety is that it's a fuel source because it has energy in it, right? And anything that has energy in it, whether it be high-voltage batteries, gasoline, propane, we have to treat it with respect, right? There's a bunch of energy on board. But having said that, there's so many safety features built into a propane system that even the gasoline vehicles we drive around on every day don't have any semblance of. It's an extremely safe fuel to have on board a school bus. And, you know, we mentioned 20,000 on the road. Well, we've seen just about every type of, you know, rollover, vehicle crashes, incidents of all types. And I have to say, you know, seeing some of that, the safety features on board really exceed what exists in just the traditional fuel world to be able to contain that fuel.
So you're feeling from a safety standpoint that versus the other, actually, fuels that are out there, and school bus has been primarily diesel. It's equal to or safer then. Is that a fair statement? Because of the systems that are put into it, like the gasoline engine having to have these different valves and valve seats to accommodate the dryness of the fuel. On the safety side, is there anything unique about it versus, let's say, a gasoline or a diesel school bus?
You know, characteristically, some of it is very similar. So the weight of it, right? The vapors are heavy, they stay low, unlike some other alternative fuels where they go up, right? Gasoline vapors also stay low. So that's familiar. You know, propane differently will just expand more than gasoline vapors, just has to do with its temperature, right? So those are the things to be cognizant of. But when you train and you get into the safety side of it, you know, there's very safe ways to work on it, handle it, and be around it without big concerns.
And it's not just safe, you know, for physically safe for the kids, you know, from the emissions part, for the technicians who have to work on them because you don't have to change the maintenance facilities because it is heavier than air, but for the environment as well. Propane is non-toxic. If you ever did have, you know, an unexpected, you know, leak from it, it can't contaminate the soil. It can't contaminate a water source. It can't, you know, as far as the air, it just evaporates. So the EPA doesn't even regulate the fuel sites for refueling these things. So it's very, very clean.
That's a big deal for any fleet that's had that happen on the gas or diesel side, because the EPA does care and serious remediation has to happen. So being able, I guess, long term, when you look at getting rid of some of your traditional fuels on site and having propane there, I mean, it's a risk mitigation for that fleet.
So that's actually, even though it's environmental that you're describing, it's actually a safety thing too, because it's not something you have to have a large spill containment to be able to handle, and you're not going to have the cleanup or the mess, and it doesn't combine with other elements. It just kind of sits out there. That's interesting.
Yeah. Now we do have to put a little stink in it, Brad. That ethyl mercaptan, because propane in its raw form is odorless and tasteless, and you wouldn't know it was there. And that's what makes it dangerous. Any energy source is going to be if it's not dangerous, then it's not going to propel something moving.
Could they have used a better smell?
No, we have to use that nasty smell
Smells
because your nose is going to be the first leak detector. If there is, a leak anywhere, you're going to smell that ethyl mercaptan long before it becomes a dangerous, capacity. So it's a.
So that odor in propane is actually a safety feature.
It is,
and it was put in there to be that, right? That's what
Exactly.
you're telling us. That keeps us safe. That way we can discover a leak quickly and remedy it quickly and keep everyone safe.
You bet.
I really want to thank both of you for being here today and talking through Propane 101 and Propane Basics. Is there anything that you have to add to close this actual episode out?
Just one thing. When we run forklifts inside warehouses, why don't we do that with gasoline and diesel?
That's an interesting concept.
I think we'd all get a little bit sick, wouldn't we?
Oh, yeah. So if you run it on propane inside the warehouse, what happens?
Nothing.
You don't get sick. Okay, so we were clean even long before the EPA started in 1972. So it's a little common sense here that propane is a very clean fuel, and it ought to be used for moving our most precious cargo.
I think we need more common sense. So I do like that. From it touching our food to fork trucks, it's common sense clean.
Very good.
So it's clean, it's safe, and that's our bird's eye view on Propane Basics.